Good afternoon and good morning. Is it still morning somewhere? Just barely? So good afternoon, good morning. Thank you everyone for joining us. Per usual, I'm going to go through some quick housekeeping notes and then we'll jump right into it. So to start with, we'll be doing a Q&A at the end of our presentation. So any questions you have, or if you're having any technical problems, just submit those in that questions dropdown and they go to webinar control panel. Quick disclaimer, all information discussed in this webinar is for educational purposes only and should not be applied directly to the administration of any particular file or claim. This webinar is being recorded and that'll be shared with you along with a completion certificate. I know I'm going to get questions about completion certificates for this webinar and the last one. The Alberta Insurance Council is meeting on March 28th, and that is kind of what we've been waiting for to release everything. So, March 28th. So next week we'll get verification on accreditation, and then we can start sending completion certificates out. We're very sorry for the holdup, but thanks to everyone for their patience. Hassan, can I get you to just toggle to the next slide there?
Yes.
So our webinar today is on building and structure investigations. We're going to be discussing the benefits of digging deeper. Our presenter is Hassan Aroba. Hassan, sorry, if I can get you to change slides one last time, and then I'll have you take it away. Hassan is a structural engineering technologist and forensic investigator. He has over 5 years of professional practice. He's a certified engineering technologist and registered building code specialist in Ontario. He conducts building investigations on residential, industrial, and commercial buildings and provides emergency shoring and repair drawings and details for damaged structures. So now without further ado, Hassan, if you want to take it from here.
Thank you, Mark. Hi, everyone. My name is Hassan, as Mark said. I also wanted to share a little bit about our forensic engineering team. We provide all forensic engineering services for all types of buildings, building investigation, structural damage. We provide practical solutions to restore or rebuild structures as needed. Also, additionally, our team also provide a complete building design services, whether architectural, structural, mechanical designs, and we have been expanding a lot in this field over the past 2 years. Just going back to the title of our presentation, we'll be talking about a topic that is at the heart of many claims, which is building and structural investigations. And that's exactly what we're going to explore, how going beyond just the surface level inspection investigation can be very beneficial. It uses uncertainty and also lead to better decisions in the claim processes especially. So let's get started. So the agenda for today, this is just a quick overview of the items we'll discuss. First, we'll talk about what's actually gained from further investigations and why it's worth going beyond just the surface level damage and the visual inspection, and how it can lead to more accurate conclusions, reduce disputes, and also support fair claim resolutions. Next, we'll look at catastrophic events, which has been like a very hot topic recently. Things like major storms and floods, heavy rainfalls, and how these high impact situations especially benefit from a deeper investigative approach. And finally, we'll go through a few case studies that will bring these 2 points together, showing how the further investigation made a clear difference in both just routine inspections and also the catastrophic claims that have been increasing a lot recently. So let's get started with the first action. So what do we actually gain from doing further investigation? When we conduct an in-depth investigation, the benefits are really clear. It provides a proper assessment of the building condition in general, and also provides a solid evidence-based findings that can distinguish between a single weather event, for an example, and also long-term issues like deterioration and decays. This objective inspection can clarify coverages if we're talking about insurers, and also can mitigate disputes, and it can even open the door for like subrogation opportunities in some cases, and allowing an ability to recoup some of the costs that were spent on the investigation. Also, I want to stress on the objectivity point. So the engineer usually in these cases provides evidence-based and unbiased opinion founded on technical knowledge, unlike other parties, if you think about it, that may be inclined towards a certain conclusion because of their limited technical insight or knowledge, maybe, or because of other conflicting incentives. Another point that maybe you don't think about it a lot, I want to discuss today, was the human perception related to these type of incidents. So it plays a crucial role actually in how people generally react to potential building damage and their homes. People's sensitivity is usually heightened because of loud noises and shaking from a storm, for an example, or even from vibration happening around them from a nearby construction. We actually get a lot of cases where people would claim that they think that their home or their building was damaged from vibration, which actually did not occur at the time in question or when they felt the vibration, nor even as a result of the vibration. This mainly happened for two common reasons. One is that people are actually far more sensitive to vibrations than their buildings or their homes. And a second reason is that most homeowners do not really know their home as well as they believe they do. People don't usually just start observing or looking for damage regularly in their buildings. It's just that these sensory experiences often create a heightened sense of alarm for people to start assuming that there is a direct correlation between the intensity of the experience they had and the physical damage that they see in the building. So not all vibrations or loud sounds would indicate structural issues to the building, and that's why we said the objective inspection is essential. In the past couple of years, catastrophic events are much more frequent and are at the center of most of claimed building damages. Even this year already, we have and we're seeing a large number of cases related to weather events from snowstorms and so on. So these catastrophic events could be from heavy rainfalls, flooding, windstorms, and snowstorms, and they create different levels of damage from just minor cosmetic damage and water intrusion or water damage into a house or a building to major structural failures in a lot of other cases. Oh, sorry. The role of an engineer in these cases extends beyond just simple damage assessment. We provide emergency support through shoring design, for an example, to temporarily support the building, through inspections, assisting contractors in managing the loss in general, and also conducting cause of loss investigations in a lot of these cases. Interesting fact about these cases that usually the culprit in many of them is actually not the weather event, if we're talking about cause of loss investigations, but actually a lot of them are mostly related to pre-existing conditions that were just triggered by the event. So the case studies we have today will explore both possibilities and show how the deeper investigation was essential in the outcome of every one of those cases. So let's start with our first case. Our first case actually happened this year. So last month in February, this was a large barn in Huntsville, Ontario, that collapsed after multiple snowstorms in February. The building was almost 100 years old, a really old building. In cases like these, actually assistance from a contractor is really necessary to help in the investigation, because sometimes we may need to temporarily shore or support the building to be able to remove some of the debris and the collapsed materials to inspect them. And this, of course, cost some money, but it helps the investigation ultimately. This is another photo of the barn prior to the collapse. You could already see some of the signs of aging and deterioration, and also clear lack of maintenance to the building exterior. So during the inspection, we had a general discussion with the building owner at the beginning, and the owner mentioned that the snow usually just slides off the roof and it doesn't really build up, but they stated that the barn just collapsed right after the snowstorms. So basically indirectly blaming it on the storm. So we examined all the collapsed materials and structural members in the building, and we found this certain pattern of deterioration, most of them that we see in the pictures. These pictures show severe rotting in the wood and also extensive insect damage from carpenter ants or termites, for example. And then given the age of the building as well, as the use, because it was mainly for farm purposes, it's very common for insects to nest in wet and damp wood members, causing the damage we can see in these photos. Especially the photo on the left, you could see the tunnels that the insects created in the wood and how they ate the fibers from the interior. It was then concluded that the root cause of this collapse couldn't have been the snowstorms, sorry, but actually due to the severe deterioration and decay and the insect damage, which are typically observed in wood material subjected to repeated and prolonged exposure to damp conditions over many years. The load from the snow was just only a trigger, but not the root cause, actually. This conclusion could also be confirmed by analyzing the design and of the structure and comparing the maximum loads that the structure can support with the actual loads from the snow on ground reported during these storms. So we selected two photos in this slide to compare between two beams from the same building. And the one on the left, you could see a sound piece of wood with the fibers and the grain still uniform and intact, even though the member was fractured. But now you can compare it to this rotted piece of wood on the right. You could see the fibers are loose and crumbly and discolored, which these are just classic signs of moisture decay from long-term exposure. So by digging deeper into this and doing a more comprehensive investigation, we're able to identify the pre-existing deterioration and decay, and determining the root cause leading to this collapse. The snow load only acted as a trigger, as I mentioned, but the underlying issues actually had been there for some time. And this case highlights how surface observations don't always tell the full story. Our next case is actually another snow claim from this year in February. This was a seasonal cottage in Gravenhurst, where the owners of the building actually only visited occasionally. Their neighbors started noticing that the roof was sinking in some areas and the walls were leaning, and the building actually looked like it was twisting somehow. So they notified the owners, and when we were asked to inspect the property, we checked how much snow this area got in January and February, because the exact date of the incident wasn't confirmed. Gravenhurst actually gets much more snow than we experience here in the GTA every year. So there was damage in almost every part of the cottage. Some walls were leaning and the soffits popped out, and doors and windows were crooked, as you can see in some of the pictures. Inside the building, we saw also major damage. The ceilings were sinking and collapsing in some areas, and a lot of water damage was found. one of the exterior walls, actually, you could see in the picture on the left, was separating from the rest of the building. We then inspected the roof structure through the attic, and we found severe structural damage actually to the roof framing, and a large portion of the roof had actually collapsed inside the attic. You could see in the photos most of the roof structure members were cracked. Inspecting the roof structure actually helped us identify the location where the collapse may have initiated, which actually led us to the valley of the sloped roof. So basically, valleys are the line where two sloped roofs are joined together, and general valleys, they are more prone to snow accumulation more than any other spot in a sloped roof. In this case, because of the excessive snow load and actually the consistent snowfall and freezing temperature in January and February, which was larger than normal amounts of snow, were accumulated on the valley, which eventually caused the collapse at this point. Again, this was also confirmed by analyzing the design of the structure to see if it was built to code and comparing the maximum loads that this roof can support against the actual load from the snow that was reported during January and February. So unlike our first case, actually here, the snow was the culprit in this one. The investigation confirmed the cause of loss and identified the source of the collapse. Unfortunately, this building can't be repaired in this condition, and it will have to be demolished. So we had to provide instructions to temporarily shore and support the building until the demolition can be completed safely. Our next case is also related to another weather event. This was in 2023, after a heavy rainstorm, we were called to inspect a house in Kawartha Lakes, Ontario. The house sustained extensive water damage during the storm, as it was reported back to us. You see the front of the house has like a little bit of a flat roof above that garage. What was interesting actually about this case that the drywall ceiling just collapsed in a very specific spot under that flat roof, and the ceiling also collapsed in the level below this area, which was a garage, which is something very unlikely to see, that you'll get ceiling collapsing from water intrusion to multiple levels. And then during our initial inspection, we found actually no apparent damage on the roof or the roofing material, which we were told that it was recently replaced about 2 years before that incident. However, we noticed that the roof drain was located exactly above the collapsed area, which has also raised a lot of questions because this is a really unusual location for a roof drain in a house. The drains are typically placed near the roof edges to direct the water away from the building without having to connect this drain to a pipe that goes through the house. So we recommended a more destructive investigation approach because we suspected that there might be other hidden issues with the building, and we got an approval to move forward with this, and we requested then to have all the drywall and insulation removed in the affected areas, and this is when we uncovered installation issues in the roof drain system actually. The roof drain that we saw in the middle of the roof in the previous slide was connected to a drain pipe, which was installed in a horizontal configuration inside the roof cavity. This is an unusual installation for a roof drain. The major issue was that the pipe was installed above the roof insulation, exposing it to freezing conditions. So the issues with this installation is the pipe is above the insulation, so it's on the colder side of the insulation, which makes it more susceptible to freezing during cold winter days, especially if there is rain and water is running through the pipe. And in this horizontal configuration, the water may not drain out of the pipe, and they would stay in the pipe. If the temperature drops, the water would freeze, and this would impose a heavy load on the drain, which may actually move it or displace it out of position. So we did a controlled water test to confirm that this was the entry point, that the drain was actually the issue, which we basically we just started pouring water through the drain and watch for leaks, which happened instantly. The leak actually started, the pipe started leaking through the fitting, connecting the pipe to the drain. So this flawed installation is what ultimately led to leaks, and that's what caused the ceiling collapse, not really just the storm. This case also highlights how this additional testing and the destructive investigation were necessary to gather more evidence and also determine the case by exposing the installation deficiencies. Still, if you think about it, that would still open a door for to recoup some of the cost of this claim, because we have installation issues and it's mainly the responsibility of the installer or the builder. Our next case actually involved a two-story home in Scarborough. This is a little bit unrelated to catastrophic events. This home, the homeowners reported like a lot of disruption in the water supply and intermittent water supply issues that started after some fire repairs 8 years back in 2015. What's interesting actually about this case, that the homeowner said that they were only experiencing this issue over the past 8 years after the fire repairs, and it would only happen during the very cold days of the winter. And this issue only started, as I said, when they moved back to the house after fire repairs were completed. So what was happening is that some of the plumbing fixtures would stop working, and like water would stop coming out of the faucet, for an example. But then a day after, they start working normally again. The insurer actually asked the contractor that did the fire repairs to go back to the house and to try to find out what was going on. But after multiple inspections using thermal imaging cameras, the contractor still wasn't able to find any cause that would lead to the pipes freezing, for an example. So we were asked to do an inspection to try to determine the cause of this, but it's a little difficult now from only visual or surface inspection to be able to determine the cause of this, especially if some of the pipes were actually freezing, and that was the reason causing the water supply disruption. So we recommended a more destructive approach to the insurer, which was declined at the beginning because of the cost and because of the possibility that the homeowner would have to cover some of the cost on themselves. So the approach wasn't approved, and we had to abandon the file. But what happened is that, again, this year, at the beginning of the winter, when the temperature started dropping significantly, the homeowner reported the same issue again. At this stage, the insurer decided to accept the more destructive investigation, which would bring us to two things. We started tracing a lot of the pipes from the water tank to the plumbing fixtures that had the issues, and we noticed the pattern that all of the fixtures were located on one side of the house, and they were all near an exterior wall, which means that there might be actually some air leakage in this area, or some of the walls may not be insulated properly. So we traced the pipes to a ceiling cavity inside a closet, which, as you see in the picture on the left side, the closet is directly adjacent to the exterior wall. And this is where we found actually air leakage in the ceiling cavity. So there were some old copper pipes. The copper pipes are more prone to have issues if there's cold air leakage somewhere. So basically what was happening is that when the temperature dropped significantly during the winter, on some winter days, these pipes would start freezing and would block the water supply. if you look at the picture on the left, you could see the two pipes. The area wasn't really insulated properly. You don't see enough insulation. There is no heat in this cavity. The pipes were really cold during inspection. But if you compare it to the picture on the right side, you could see the two pipes. They are actually on the interior side, so they would be protected with the heat, and the cavities are insulated properly as well, as you could see. So by approving this destructive investigation, the insurer actually may have saved a lot of cost on this, because the pipes may have burst and started leaking, which may have caused much more damage than we would expect. So this investigation actually helped us determine the location and the cause of the water supply to be able to fix it properly, and also expose the construction deficiencies, because this was confirmed to be part of the scope of work for the contractor at the time of the fire repairs, and the contractor was responsible for this, and they had to go back to resolve the issue, and also this resolved an ongoing dispute with the insured for a few years. Back to CAT claims, actually, our last case was a brand new high-end custom home in Stouffville, Ontario. The house was only 3 months old when a storm occurred, causing flooding in the basement. There was also a lot of reported damage and cracks in the basement concrete floor. Here's the sequence of events in this case. The insured had started noticing small cracks in the basement floor before the storm, actually. So they advised the builder to come back and see this, but the builder kept insisting that those cracks are normal in a new house, which is typically true, by the way. Small shrinkage cracks will happen in a concrete floor in the basement almost all the time. We were also told that during the storm, the sump pump in the basement had failed because of a faulty installation, which possibly contributed to the basement flooding. But a few days after the storm, the homeowner noticed that these cracks started getting wider and wider and showed up in all other areas in the basement. Again, they called the contractor and the builder to come back. The builder insisted that those are normal cracks, and they might have just worsened because of the flooding. In our initial inspection, we could see that these cracks are not normal, actually. They were everywhere in the basement, extending in all directions, and some of the cracks were actually wide enough to fit a pencil in them, and we could see water actually seeping out constantly in these cracks. So we started digging deeper into this, and we obtained the construction drawings of the building, and we did a full review of the drawings when we noticed that actually the structural engineer that designed the building clearly stated on the drawings that there is a possibility of a high ground water table in this area, and that the builder must notify the engineer if the underground water was present in the excavation during the construction and the foundation work. So the engineer actually put a clear note that he must be informed to do any necessary analysis and revise the foundation design if needed. So we spoke with the contractor, the builder, to verify if any of this actually happened, and the builder actually confirmed that the underground water in fact was present at the time of the construction. Water kept coming back into the excavation, and they were pumping the water out regularly. The builder also confirmed that they had missed the engineer's notes on the drawings, and they did not actually inform the engineer of the issue during the construction. We conducted some preliminary analysis, and we determined that the slab was actually under-designed for this high ground water table, and it wouldn't have been able to support the high hydrostatic pressure from the underground water, which was likely actually raised during the storm because of the sump pump failure, which ultimately was the main cause of the cracks. In this case, the additional investigation actually helped us confirm our initial findings that these cracks couldn't have been normal from the beginning, and helped us expose all the construction deficiencies, which were the primary cause, and also revealed the responsible party, which is, of course, the builder. So if this actually slab was designed properly from the beginning and constructed as indicated by the engineer, this type of damage wouldn't have actually happened. Thank you, guys. That's everything we have for today. I hope this was informative and clear, and let us know if you have any questions.
Okay, thanks very much, Hassan. We do have some questions already. So why don't we start tackling those, and then we'll see what else trickles in. So this first one is, this came in during the first case study.
Okay.
So are there certain trees that have a greater chance of falling over than others, say due to root depth or the size of the trees?
So we're talking about the first case?
I believe, yeah, that's when it came in.
Not necessarily. Like even just some trees have very. I just want to make sure I heard the question properly. They were asking about trees, right?
Correct.
No, not necessarily. Some trees, large trees, only branches sometimes fall, and even just a branch could cause damage to a building or a roof structure, but not necessarily that certain trees are more prone to fall than others. I wouldn't be able to confirm this for sure. I'm not an expert in trees. Maybe
Yes,
an
yeah,
arborist can.
yeah.
Yeah.
But anecdotally, you haven't seen more, of one tree than another.
No.
Yeah. Perfect. So this also came in during the first case study. What was the stated root cause of the collapse? Was it the snow or was it the deterioration?
So the stated root cause was actually the snow. The owner made it clear that they are claiming this because of the snowstorms that happened in February. Yeah, so we agree that the snowstorms were actually excessive. We've got a very large amount of snow in a very short period of time in February specifically. But think about it. The building has experienced a very large amount of storms over the years. And how come the building, you could just think about it this way, how come the building just collapsed now? Especially as well, the roof slope was very steep if we're looking at it in this picture, and the owner himself confirmed that snow doesn't really accumulate on the roof. It's just the snow would have been a trigger to show all the issues that the building already had. If the building didn't have all of this deterioration, all of this insect damage and the decay, it wouldn't have collapsed.
Okay, so to be clear, the owner stated that it was due to the snow. Your findings showed that the snow was a contributing factor and maybe the final straw, but not the root cause.
Not the root cause, yes.
Okay,
that's
perfect.
correct.
Yeah. So this one came in during case study number 2. Again, this might be somewhat anecdotal in terms of your answer, but would you say that metal roofing is better than an asphalt shingle roof for getting rid of snow or preventing buildup, maybe?
So the issue with metal shingles that they are not very good with low slope roofs. So metal roofing is ultimately better than shingles in general, and it has a much longer lifespan. And snow slides much faster off metal roofs than shingles. But at the same time, we've also seen cases of buildings collapse even when they had metal roofing. But just to answer the question, yeah, metal roofing is ultimately better. It has a much longer lifespan than shingles. Less maintenance may be required to metal roofing as well.
But I think the question referred to, would snow be more likely to slide off a metal roof and not build up? Okay.
Yeah.
Perfect. Thank you. This is referring to the last case study, the cracks in the foundation. What was the remedy for the house in the end?
So unfortunately, the issue is that these cracks will keep extending, and if the slab doesn't get changed and a proper slab, thicker maybe or more reinforced, is installed, cracks will always happen. Cracks will come back. So the entire slab, unfortunately, would have to be removed and reconstructed properly, which is a major job because this basement was finished and it would have been a large amount of work to do. So the proper remedy is actually to rebuild the slab, which is doable. It's doable without having to do like major demolition in the house. It's just the slab itself would have to be repoured properly because these cracks will only get worse. Think about it. Think about it as you think about a pool. So a fiberglass pool, for an example, the only way to keep it into the ground is to fill it with water. So if the pool has no water in it, it will start cracking instantly because it can't resist the soil pressure. And if there's groundwater, it would even make it worse. It's the same for the house and the foundation and the slab of the house. Think about the foundation and the slab as the pool, and then the house structure above it is actually the water that keeps it into place. So if there's no resisting load from the house itself to resist the hydrostatic pressure, the slab would start cracking. And if the slab is not designed properly, it wouldn't be able to resist the pressure from the soil and the water underground.
Fantastic. Oh, and just a quick follow-up from the same person. So it had nothing to do with perimeter drainage, but purely the foundation installed was not adequate for the water table.
No. So the perimeter drainage, even if it was there, it would have delayed because we said that the sump pump failed, so it made the effect much more visible and happened faster. If the sump hadn't failed, maybe it would have delayed this a little bit, but it's just a coincidence that the sump pump failed, so drainage around the foundation didn't happen properly, so which made the damage show up faster. So the perimeter drainage wouldn't have been an issue, the main cause of this case.
Okay, fantastic. So where is it? I have two questions here about basically the acceptable thickness of the slab, or how this slab should have been done to avoid this.
So in the building code in Ontario related to homes doesn't require the basement slab to be any thicker than 4 inches. Doesn't have to be reinforced, just 4-inch concrete slab poured on the ground. But the issue is that if you have groundwater very close to the surface of the basement, during the excavation, the slab would have to be reinforced and a little thicker. 6-inch thick reinforced slab would be more than enough actually to resist this. But in the typical conditions, 4-inch slab is more than sufficient, or even 3-inch is more than sufficient. But if you have groundwater table like this, an engineer would have to design the slab so it can resist the water pressure.
Okay, thank you. So quite a few more questions. I'm just another follow-up on the slab. What would reinforce the slab?
Usually their steel bars are good enough, and there's also, like, if you've ever seen the wire mesh that is used, maybe it looks something like the screen that you'd see in a window. The wire, it's wire reinforcement made that looks like a mesh, and you can reinforce the slab with it, which is also just for a house is more than enough.
Okay, thank you very much. Here we go. In the case of the home with the plumbing issue, this is the one with the freezing.
Yeah.
Why would this only have started occurring? Oh, I think this is just maybe just some confusion here. Why would it only have started occurring after 8 years, or was it happening right away?
No. So it actually, the homeowner reported that it started happening right away. It would happen every winter, but only when temperatures were very low. But it didn't happen like 8 years after. No, maybe I wasn't clear about this. They said that this was happening for the past 80 years, right after they moved into the house, after the fire repairs are completed.
Okay, yeah, I thought that was what the case was. Okay, thank you. Case study number 3, which is the drain.
The drain, yes.
Yes. What was the cause of the damage to the ceiling on the level below the top level?
So the likely the water was actually, or the drain was leaking for a very long time. The drain didn't just start leaking in this storm, and we actually found mold damage in a lot of the walls, the interior walls in this level. So the water was actually draining through the walls and going down into the ceiling below and building up into the ceiling until the ceiling failed and collapsed. So water was actually leaking into that roof cavity and then moving towards the walls and draining through the walls down to the ceiling below. And the mold confirms actually that this may have been a long-term exposure. It's not just this specific storm.
Okay, fantastic. Okay, thank you. Still more questions. So, but it's good. We've got time. So here's one that, again, this might just be based on your experience. Do you find building construction of the 1980s less superior than that compared to the 1960s, which is being affected more by serious storms that we are now experiencing?
That actually might be true. Look, if we're talking about homes specifically, I believe that myself, I believe that there's a major issue with the Ontario building codes and the building codes in Canada in general when it comes to homes. The issue is that the homes are exempt from a lot of the major structural requirements that you would apply into, for an example, a one-story industrial building or a one-story commercial building with a normal use like a restaurant or a grocery store. So there are certain checks that we don't really need to do for a home that we would have to do in a different type of building with a similar size, for an example. And this may make homes specifically more prone to damage from extreme weather events, but that might actually be true, that homes built in the 80s and the 90s were a little more or had better construction because in the building codes were more developed at this time. So the first building code actually was in 1975. Before that, it was mainly based on common practice or municipality bylaws, local municipality bylaws, and it wasn't consistent. The construction of homes wasn't consistent everywhere. So yeah, anything after the 1980s would have been much, much better in terms of construction of single-family homes.
Okay, oh, it's okay. You're finding it better after the 80s with the
Yeah,
introduction of the building code. Okay.
yeah.
What is the justification for, I guess, the difference in leniency on a residential building versus a commercial building?
Um, there's
Sorry.
something that we call the importance factor. So importance factor, if you think about it this way, a commercial building is more has more possibilities of much more people being in it at a certain time than in a house, for an example. The way the house is designed may not consider certain uh, um, like excessive storms, for example, or damage that could happen from a windstorm. But it's mainly based on the importance factor, and that commercial building has more possibilities of much more people being in it at a certain time than in a house.
Okay. Oh, great. Yeah, that answers my question. Um, we are back. Oh, no. Still in case number 3. Could it be argued that the designer of the roof was partially at fault and not just the installer of the drain pipe? For example, if the pipe was placed at the edge of the roof, the problem may not have arisen.
Another another good question. So this specific case, if we're talking about this roof, the roof already had 3 other drains in the corners at the edges of the building. So this specific drain wouldn't have been necessary from the beginning. It just collected water, and the installation itself is unusual. The location is unusual. So it wasn't the building had already 3 other drains. So can't really blame the designer. I mean, we can't really confirm if actually the designer uh, put a drain in this location, because another issue that we see with construction of homes, that the building code doesn't really require you to show location of roof drains or even plumbing drawings for a home. The plumber is more than qualified, a certified plumber, to do this uh, um, this judgment on their own. The designer wouldn't have actually specified locations. It's a high possibility.
Okay. Still in this case study, as the pipe was gathering ice and getting heavy, can you address the lack of pipe hangers?
That's a good point. The pipe was actually too long to be installed without hangers. The hangers may have been another issue. If the pipe was had hangers, it may have been able to resist the load in case of freezing, and it might had not been displaced out of position. So the hangers is actually another point that we considered. That's a very good question.
Yeah, a lot
If
of,
yeah, if the hangers were installed, this may have been a much slower leak than it was.
okay, yeah, some excellent questions coming in.
Yeah.
Here's another one on case study number 5, foundation, the slab, sorry. Um, the engineer was aware of the high water table issue, however, left it up to the contractor to confirm if they find water during excavation. Water level could have been lower during excavation, but might have risen later. Isn't the engineer liable in this case?
Okay, so there's no way for the engineer to have been aware unless a soil test was done before the construction. But this is actually a general comment that you would see in the design of a lot of custom homes, that the soil conditions has to be verified before the foundation is constructed. You can't really, I don't think you can really blame the engineer for something they didn't know. The engineer wouldn't have known that the water table is high. They may have made an assumption based on previous experience, but there was a big possibility that the water table may have not been high. It's just like a very common precaution for engineers to take, especially in terms of the construction of large custom homes, because the basement slab would be much larger in that case in terms of area. So it's actually a good speculation or a good assumption to consider. Maybe this could have been like conveyed to the contractor in a more clear way, because it's very common that not every single note on the drawings is read or considered. So, but I don't think the engineer can be held liable for this, especially if we go back, if they go back and say, well, we warned them on the drawings, even if it wasn't done personally or face to face. But yeah, maybe it would have been handled in a better way. But I don't think the engineer would be mainly liable here.
Okay. People, we're still in this case study. Was this covered? You might not know this. Was this covered under their insurance,
We
or was this
actually
liable?
we actually know that this was not covered. The claim was denied, um, uh, based on the findings. And the builder probably would have the builder is responsible, of course, but the owner would probably had to take other actions to get this remediated by the builder. But we know for sure that this claim was denied.
Okay. This is a response to the previous question about whether the engineer was responsible or not. Should the engineer go and inspect the site?
So another issue with the building code related to homes, inspections by the engineer are not required. Only the city or the municipality inspector is required to conduct an inspection. And as long as the construction doesn't deviate from the drawings, the engineer is not required to go and do an inspection. So the provincial laws and the municipal laws and the Building Code Act doesn't require the engineer to do inspections for this type of home of construction, for homes and small buildings.
Okay. So still in this case study, but so you mentioned that cracks in a newly poured slab are normal, or normally they form. Do you see them more often or not? Do normal cracks have any type of pattern? And is there any way to minimize that?
So the cracks happen in a basement slab specifically because of the large amount of concrete poured together at the same time, and because of the difference in temperature between the time when the slab was poured and the temperature that the slab is exposed to now or at another certain time. So the type of cracks that are normal, they're very thin, they are hairline cracks. You may not be able to see them unless you look very closely, and they wouldn't extend in all directions as we see in the pictures here. They would just start dissipating when you follow them. A good way to minimize this is increasing the thickness of the slab and the reinforcement as well. Adding the reinforcement would make the slab much less susceptible to even the shrinkage cracks that would happen normally. But again, it's uncommon and it's not necessary unless we know or we're aware of other issues in the soil or the groundwater table, as in this case. But the best way to reduce these types of cracks is reinforcement and making the slab a little thicker. But again, the shrinkage cracks, they're very, very thin, they're hairline, and they're normal, they're harmless.
Okay, was the floor in the case today, was it by chance a heated floor? That was a question that just came in.
No, that's actually a good question. Oh, actually, this one was a heated floor. Actually, that's correct. This was a heated slab. Yes, yes. Sorry.
Okay,
That's
no,
correct.
interesting. Good
Yeah,
question.
yeah.
I think after this webinar, everyone is going to go downstairs and very closely examine basements. Okay.
It's just the pictures may be a little like fooling, but the cracks are really wide. Like you would never miss them if you're just walking around the basement.
Okay, we've got time for a couple more. Again, yeah, great questions and lots of them. Have you encountered any situations where someone has intentionally flooded areas of their home?
I didn't actually. That's an interesting question. No, no, we haven't. But we always, even if we suspect that there may be something different than what was reported, like certain information were hidden on purpose, we would always assume the benefit of the doubt and um, try to consider at least the possibility of all the information we were given are actually honest and true. But we've never encountered a case like that, no.
Okay. Let's see. Last one. Did that, it's covered. Case study number 1, the barn.
Okay.
You know if coverage was afforded for that one?
No, this was also denied.
Okay.
This case, we were told that it would be denied. It wouldn't be covered. Because it's clear, because we made it clear in our findings that this is a long-term deterioration and decay, and I don't think most policies would cover this. It depends though, but we know that this would have been actually denied.
Okay, great. This one I think is related to case study number 2. Yeah, I know we had talked about the possibility of a metal roof and snow sliding off, but would freezing rain that adheres to a roof encourage more snow load accumulation as the snow does not slide off as easily?
If they mean by freezing rain like ice damming and ice sticking to the roof, if the roof is constructed properly and insulated properly, ice damming wouldn't happen. But yeah, ice damming actually is an issue with shingled roofs, because the ice damming would stop the rest of the snow from melting and falling off the roof, and it would start seeping through the shingles actually and cause damage on the interior. So if this question is about ice damming, yeah, ice damming is an issue and could actually, but it wouldn't be a major factor in this case. This case is mainly because of the excessive weight of the snow that accumulated on the roof. Ice damming could cause other cosmetic issues or other performance issues in the roof and the ceiling.
Okay, we'll do, this is the last one. And again, this is just, this is off the cuff, and I'll just point to our disclaimer at the beginning that all information in this webinar is strictly educational. What construction recommendations above code would you give to any homeowners who are trying to prevent common damage? And again, putting you on the spot here, so.
It's always, so if we think about the building code provides the minimum requirements or the minimum criteria that has to be followed. But I always think, and that's my own belief, that if an engineer or a designer is doing the minimum, then they are not a good, or they're not a competent designer or engineer. You should always do more than the minimum, because most of the major issues that we get our homes are related to performance as well, in terms of heat and sealing the building properly to to protect it from water exposure and water ingress. So it's always better to just go beyond the minimum and not just accept the minimum requirements of the code. So we could, it's uncommon to do anything other than wood construction in terms of, if we're talking about homes, but there are certain ways to make the homes more, if we say more stronger, if we're thinking about it this way, in terms of resisting loads or major weather events. So doing the minimum is not good enough. It's always it's always better to go more beyond this. So yeah, there are certain ways. It's just there isn't really one specific way to do this. It depends on the design of the building, the size, the location as well. The location plays a big difference, and not just an inspection by an engineer was another good point. Making sure that the construction is being inspected regularly by the engineer. Sometimes inspection by municipality is not enough. So that's another thing to ensure quality control and no corners are cut, and all the design requirements were covered in the construction.
Okay, excellent. Thank you everyone for the questions. Really, really great questions today. Hassan, and well, thank you as well very much. Great job on the presentation. Great job fielding all those questions. If I could trouble you to go to the last slide.
Yes.
Just a very quick announcement, and then we'll get going. I see people tailing off already. Okay, so I'll take this opportunity to announce we are doing the national tour. We are doing it again in person for the first time since I think 2019 was the last time we did the national tour in person. If you're not familiar with the national tour, it's a series of presentations that we do. This year we're going to be doing, we'll have 4 presentations at each location. So that's 4 hours, it's 4 CE credits for those provinces where it's applicable. Here are the dates and the locations for anyone who wants to kind of just jot those down and block off that time on the calendar. They're going to be running in the morning so it'll be 9 a.m. until 2 p.m. and that's with a 1-hour lunch break. And yeah, we're very excited about it. We're really looking forward to getting back out in person and seeing all of you. And just kind of stepping away from our desks and our screens for a morning. So yes, hope to see everyone out there. If you have any questions about that, please feel free to reach out and let us know. But that's the end. That's 2:02. So wish everyone a very good day. And again, thank you, Hassan. Thank you very much. Everyone, take care.
Thank you, Mark. Thank you guys for attending. I hope it was informative. Thank you.
Sorry, let me just say, so I just see a question. The cost for the national tour, it's free to attend, and we'll be sending out an official email newsletter with all these sign-up details and links. If you're attending this webinar, you will get the email. So, yeah, just keep an eye out for that. Thank you very much. Bye.